Multi-times Monte Carlo rendering for interreflection reconstruction. Motivation. Inverse rendering bases the physical rendering and utilizes the neural network to learn disentangled materials that can be seamlessly plunged into the industrial pipeline for further manipulation from multi-views of a sense. However, the neglect of indirect illumination by existing methods leads to geometric and material ambiguity, especially in multi-object reflective scenes. In this paper, we proposed a full inverse rendering method, Ref-MC2, which considers interreflections during ray tracing to improve the decomposition of explicit materials and environmental lighting. Related work, implicit neural representations. Neural implicit representations have achieved impressive success in many computer vision and computer graphics tasks. These methods use neural radiance fields to capture color and volume density, generating photorealistic novel views through volume rendering. To produce a high-quality geometry, follow-up works use a function to associate sign distance field, SDF, and volume density. The surface mesh can be extracted from neural implicit surfaces by marching cubes, and this 3D asset can be further applied in other applications. Although neural implicit surfaces have achieved impressive performance in geometry reconstructing and novel views synthesis, they do not obtain the fundamental materials of PBR, which limits their flexibility in downstream tasks. NDifrect introduces the full inverse rendering that estimates shape, materials, and environmental light into gradient-based optimization. However, it does not consider the shadows, leading to the entanglement of materials. Overview. We perform Monte Carlo sampling at the viewpoint. When the sampling ray from the point is not blocked, it is the direct illumination from environmental lighting. When the sampling ray hits an object, we divide this indirect illumination from the object into diffuse light and specular light. For diffuse light, we pre-compute the coarse diffuse color under one-time sampling and store it as a diffuse map to query during the multi-time sampling. For specular light, we only need to partially trace the rays in a small specular lobe along the reflective direction. The gradients are backward along the tracing path and are passed to optimize KD, Corm, normals, and environment maps. Comparison. Material decomposition. Relighting. Thank you.